Hey everyone, I would like to present Thinking Inside the Box, a structured approach for full stack app development. My name is Samuel Calderon. I currently work as an R-Shiny developer at Epsilon. So in a nutshell, what I would like to present is that for APIs, we don't have a stable framework for developments, such as we have for Shiny developments. For Shiny, we have Rhino and Golem. They have their differences, but they allow you to have a structured approach on how you will develop your application. We don't have that for APIs. So how can we kind of overcome this? For Rhino, you will get a pretty particular structure. For Golem, if you are familiar with package development, you will get pretty much the same thing. But for Rhino, you will have an app folder that will allow you to have subfolders for different kinds of assets for your application. Two important folders are the logic folder, which here you will introduce pretty much functional logic for your software. And you have the view folder where you will define your pages, your web components, etc. So I'm explaining this because it will be useful later. On top of that, you also get a testing folder and some other files that allow you to define configuration, dependencies, and in turn, it will allow you to create a log file. So for Golem, you will have, as I said, something pretty similar that you will get for package development. For Rhino in particular, you use an approach called box modules. So this is an alternative approach than just plain library calls or use of R packages. Basically, what this allows you is to define an R file and later use it as if it was a package on itself. So here you can see that in this code we are importing a subset of Shiny objects or functions, right? But we are also in the next lines, we are importing a box module that has an UI and a server function. These are used within the body of this new UI object we are creating in this file. So you can see that pretty much you will import what you have in this file as you will import a package itself. So this is the advantage you have with box modules. Basically, you can have a structure as wide or as deep as you want, and you will be able to import from that structure of your logic. So how does this relate to APIs? Here I am presenting the hello world of both Shiny and Plumber. For Shiny, you will typically start developing something in the global environment. What this means is you will have your app.r file. You will use library to call all the packages you need for your application, and then you will start defining your objects. In this example, we have UI server, and at the end, we have the Shiny app, which leverages both to create your application. For Plumber, you have something pretty similar. You have your plumber.r file, and inside this, you will define your endpoints using syntax with roxygen 2, right? You will define them as functions, and you will add comments and tags from roxygen 2 to create metadata for these functions. And at the end, this will be rendered as endpoints for your application. So the problem with this is that as your development starts growing, maybe your application will need at some point to be splitted into different files just because one single file will get too big. And a project can grow in having lots of new files that will need to be called from a central place, but also can grow with having lots of collaborators. So if you're just developing an app for yourself, I mean, only you are the owner of this application and the one person that can do changes. You can basically do whatever you want. But if you want some collaboration from other people, or you work within a team or teams of teams, uh, you will need to add certain structure that every member of this team needs to follow. Okay. So for when this happens, it is pretty important to have a framework because you will have a shared like mentality and tooling for that. So with Rhino, so first of all, with Golem, you will get everything you already had for package development. So that is pretty useful. I will focus on Rhino because it's not as widely known as, or maybe uh, as widely leveraged as Golem, right? So for project structure, you can use for Rhino, you can use the box structure that I already showed to you, as wide as and deep as you want it. The scaffolding, meaning the when you initialize your project, you will get an application or a folder structure. Okay, when you initialize with Rhino, you can get this. Then you have other supporting functionality such as dependency management, testing strategy, versioning, dev pro configuration, logging, CI/CD practices. Right? I will argue that both Golem and Rhino are pretty good to provide with this kind of tooling. But for Plumber, the idea I would like to share is that you can leverage what you already have for Rhino. And I'm telling you this because I think the box functionality is pretty useful and allows you to scale pretty well. Okay, so I'm here to present some patterns we are using. I'm calling these patterns because this is still not a framework. It's not quite built in this way yet. For context, the applications we are using APIs for have two scenarios right now. In both cases, the API will be consumed, but a second different application. Okay, so this is why we need the API in the first place. So the first scenario is that we will have a database, but both the app and the API will connect to this database through a shared parsing logic. Meaning that basically that we will define some kind of types or classes for the objects that the database returns, and then both the API and the app will use these types or classes. But we need a second application needs also to share this logic. So this is why we create the API. And this is a monorepo, meaning that all the code structure will be shared between app and API. So in the second scenario, we have again a monorepo, but in this case, the application can only consume whatever the database has through the API. So these are two possible scenarios. I think this generalizes pretty well to things you can encounter in production. But in all cases, you have a second application. This is why we use this monorepo. It might be that for your particular use case, it makes sense to split API and app in two different repositories. But for our concerns, that wasn't necessary. Okay, so what are the patterns? First of all, we commit to use box. You can see here that everything is designed to be used as a box file, as a box module. So this is an example of how we import functionality from Plumber. You use the box use function. Inside, you define the name of the package, and inside the brackets, you define the functions you want to import. We don't use source because it has implications for the global environment and will basically you lose the gains you will get otherwise from box modules, right? Because you will create namespace conflicts, which is the main thing that box allows us to avoid. So on top of that, we use the box linters package. This was developed by Epsilon team, and we use this to enforce good coding practices. In this particular example, you can see that the functions we import from Plumber are listed in alphabetical order. So later, when we want to remove or add a new one, it's pretty easy to find in which line should we focus to do it. Second thing that we are committing to do is to take advantage of the programmatic API. We are not using our Oxygen 2 style comments, but we basically use instead of creating a comment defining, for example, a get method for an endpoint, we will use the PRGet method. The same for post. And if we want error handling, we will create a new router that will include this error handling logic. And you can see this in the left side of the screen, where we initialize an empty router and we add our methods endpoints into that router itself. So later, when we are in the plumber.r file, we import the box module client as it was defined in the left side, and we just mount the router. So this is basically equivalent to what you will do with Shiny models. So this is the idea we want to translate from Shiny to plumber. So this is a high-level example of this. Shiny modules will allow you to encapsulate UI and server logic, and routers allow you the same thing for API endpoints. They are reusable. They allow you to have name spacing. In the case of plumber routers, you get this from the route itself that you define, but also you get it from using box modules. Okay, these are composable and they allow you to have separation of concerns. So basically, think of plumber routers as the same as you do with Shiny modules for Shiny. Okay, for scaffolding, this is where we stop. The framework is no longer useful by itself, right? Because here we have to manually do our own scaffolding. So you saw that for Rhino, you get an app folder. So when you want to use to develop Plumber, you will create an API folder and you will include there your own scaffolding, right? So for us, is defining a folder for constants where we will put things such as the database credentials, using also the config package. So we will get different credentials for each deployment environment. We will create a routers folder and a utils folder. Utils is a generic name. You can call it logic, you can call it library, you can call it source, whatever. But basically, you will have functional logic that you can reuse then in your routers. So routers will be the equivalent of the view folder that you will have otherwise in Rhino. Basically, your main component, right? Things that you will then import into your main folder. So you could add different directories on top of this, such as a directory for filters or middleware, hooks, types, class. It will be really ideal if you have these types of classes defined also globally that then will be shared between your API and your app. This is just an example. And you can define a folder for your API specifications. And you can see that everything here it will be inside the API folder. So you get a really, really nice separation of concerns between your API and your app. Of course, then you will need to enforce good development practices, right? Such as for example, never importing something you define in your API folder into your app folders. So, but you can see that we are just presenting a spark of what could become someday a framework for API development. For continuous integration, this can be shared. Rhino provides the lint-r function that by default only allows you to run your linters inside the app and test folder. So we create a custom linter that allows you to also use it in the API and Plumber R files, correct? So you will call this custom linked R in your IDE. You can define it in your R profile, or you can also later use it in your continuous integration workflow file. For continuous deployment, since this is a mono repo, these changes are only necessary because of this. You will define logic that will prevent your RS Connect bundle to be confused. For example, here we do this by adding app.r to the ignore file for RS Connect. So when the time comes, you have one deployment for your API and a different deployment for your app, and they will not have the API will not have app.r and the app will not have plumber.r. Hopefully this is not very confusing, but basically this is the point where you get this separation of concerns between what you deploy for your application and what you deploy for your API, of course. So some final comments I would like to add that in our case, we were able to piggyback on Rhino because we were dealing with mono repos. And you can see that it made sense to share classes, to share dependencies, because that was all a single monorepo. So what about standalone APIs? Just using Rhino init will get you 90% of the way, as you saw before, but it will add some cost to your development. You will depend on Rhino and all of its dependencies, and this might not be necessary for your API, correct? Also, you will get some app scaffolding that will not be useful for you if you are developing just a standalone API. So while this gets you 90% of the way, then you have to manually add some extra things. So I will say that this remaining 10%, it is important enough to say that we don't have a framework for APIs. So hopefully this was all clear. If you have any opinions or questions, feel free to contact me. You can scan this QR code that will lead you to my LinkedIn page. So I'm open to any questions, comments that you could have through this media. Thank you.